Good morning, students. Myself, Pragnesh from Om Engineering College, Junagadh. Today we have met here to discuss some frequently asked examples on matrix and determinants. So let us first recall some basic definitions about matrix, and then we quickly move to examples which are most important related to exam. Okay, so if you look at the PPT, just recall the definition of matrix. A matrix is nothing but an array of elements which arrange in rows and columns. So here is the matrix which has m columns, 1 2 3 up to m columns, and n m rows and n columns. So this is the matrix m cross n. We have horizontal are rows 1 2 3 up to m, so there are m rows and n columns. So we can show it generally. This is aij, that means I is the number of row and j is the number of column. This is such kind of arrangement of elements. This is called matrix. Let us look recall some basic definitions about matrix. First, this is the row matrix, which is there is only one row and n columns. So this is called row matrix which have only one row. This is the column matrix which have only one column and m rows. So this is a column matrix. The square matrix, the square definition of square matrix is there are number of rows and number of columns are equal. So this kind of matrix is called square matrix. Here is one example of a square matrix which have 3 rows and 3 columns. So this is the example of a square matrix. In matrix, in our syllabus of diploma, we mostly deal with square matrix. So this is most important to understand what is square matrix. So there must be a number of rows and number of columns are equal. This is the identity matrix, where there are all diagonal elements are equal to 1 and the rest of elements are 0. So this is the identity matrix, square matrix with ones on the diagonals and zeros elsewhere, right? So this is the 4 by 4 identity matrix. In the same way, we should have 3 by 3, that is 1 0 0 0 1 0 and 0 0 1. For this is 3 by 3 identity matrix, and here we can see in the PPT 4 by 4 identity matrix. And the most important things, how to find the transpose of a given matrix. We know that our matrix is A11 A12 up to A1n, which is the first row, and A12 A22 up to A2n, which is second row. When we want to find the transpose of the given matrix, we need to interchange rows and columns, corresponding rows into corresponding columns. So if we change first row, which was A11 A12 up to 1 A1n in the first column, then we will get as I shown in the PPT, the first column is A11 A12 up to A11. In the same way, if we interchange all rows in the corresponding columns, then we will get the new matrix which is called transpose of the given matrix. So here I have shown the transpose of the matrix A, which we have discussed in the first PPT, first slide, that A11 A12 up to A1n. Here is the one first column, and there it was a first row. So this is the transpose of a matrix, which is denoted by A dash or A raised to T, which is T for the transpose. So this is the definition of transpose of a matrix. Now look at the addition of two matrices very quickly. Okay, so if we want to sum the matrix A and B is possible when there is a number of rows and number of columns are equal in matrix A and B, and if we want to add both the matrices, then we need to add the corresponding elements of matrices A and B. So here if we look at one example, then if there is a matrix A and the matrix B is like that, 1 minus 2 2, 0 or minus 1 3, and if the matrix B is minus 3 0 4 and 2 1 4, 2 1 minus 4, then A plus B, we want to A plus B, then we need to add 1 with minus 3, which are corresponding elements. So we need to add that elements. So 1 minus 3 is equal to minus 2. In the same way, we need to add these two elements which are corresponding elements, then we get minus 2. In the same way, if we get all these additions, okay, corresponding elements, then we will get, after all, addition of matrix A and B. The final answer is minus 2 6 2 0 minus 1. So in this way we can add two matrices with the addition of corresponding elements. And note that we can add only two matrices which have the same number of rows and same number of columns. So just note that A plus B is equal to B plus A. That means the addition of matrices is commutative. So A plus B is equal to B plus A. Here I mentioned that matrix addition is commutative. Matrix addition is associative as well. So A plus B plus C is equal to A plus B plus C. Now look at some more example manually. So if we have given a question like this, example, if A is equal to 2 minus 1 0 5 1 9 and and 3, just a minute, I think so. If A is equal to 2 minus 1 0 3 2 minus 4 and 5 1 9 and B is equal to 17 minus 1 3 minus 24 minus 1 minus 16 and minus 7 1 1 and 4A plus 3C is equal to B, then we need to find matrix C. This is the example which asked in March 2009. Okay, so here we have given two matrices A and B, and we need to find we have also given 4A plus 3C is equal to B, and we want to find the matrix C. Before we start this example, we should understand how to multiply a given matrix with any scalar. So we first need to understand the scalar multiplication of matrix. Okay, so let us look at the PPT. Then the scalar multiplication of matrices if A is any m cross n matrix and S is a scalar, then we let Ka denote the matrix obtained by multiply every element of A by K. So if A is equal to 1 minus 2 2 0 1 3, and then 3A is equal to, we need to multiply all the elements of matrix A with 3. So 3 is a scalar and A is a matrix, so this is the scalar multiplication of A with 3 is equal to 3 minus 6 6 0 minus 3 9. These are some properties of scalar multiplication. Now just quickly look at our example. Then here we need to find 4A plus 3C is equal to B we have given, and we need to find C. So here 3C is equal to B minus 4A. So we need to find first B minus 4A. So 3C is equal to B is equal to 17 minus 1 3 minus 24 minus 1 and minus 16 minus 7 1 1. Okay, 3C is equal to, this one is our B minus 4A. So 4 is a scalar with the multiplication of a matrix A, which is 2 minus 1 0 3 2 minus 4 and 5 1 9. So 3C is equal to B minus 4A. So here this matrix is as it was, and multiply the matrix A with 4. So this is minus 8, 4 into minus 1 is equal to minus 4 0 12, 4 to ja 8, minus 4 into 4 minus 16, this is 20, this one is 4, and this is 36. And subtract these two matrices with the subtraction of corresponding elements. So here 17 minus 8, which is equal to 9. Here 17 and 8 are corresponding elements. So 17 minus 8 is equal to 9. And the same way here we have minus 1 minus 4, this is equal to minus 1 minus plus 4. So minus 1 plus 4 is equal to 3. 3 minus 0 is equal to 3. Minus 24 minus 12 is equal to minus 36. Minus 1 minus 8 is equal to minus 9. Minus 16 minus plus 16, which is equal to 0. Minus 7 minus 20 is equal to minus 27. 1 minus 4, which is equal to minus 3, and 1 minus 36 is equal to minus 35. This is equal to 3C. We need to find C, implies this is equal to 3C, so we need to find C. So C is equal to 1 by 3 9 3 3 minus 36 minus 9 0 minus 27 minus 3 minus 35. So this is our final answer of C. If we want to divide all the elements with respect to 3, then we will get 3 1 1 after dividing by 3. This is minus 12 minus 3 0 minus 9 minus 1 minus 35 by 3. So this is our final answer of C. So in this way we can, using the addition, subtraction and scalar multiplication, we can find the value of any matrix. So this is the example which was asked in March 2009. Let us look at one more example of addition and subtraction. Let us look at the second example. Okay, this is the second example where A is equal to 2 3 1 0, B is equal to 4 1 2 minus 3. Then prove that transpose of A plus B is equal to transpose of A plus transpose of B. We need to prove transpose of A plus B is equal to transpose of A plus transpose of B. This is the example was asked in November 2006. So here first we will prepare the left hand side. So first we need to find A plus B, which is equal to 2 3 1 0 plus 4 1 2 minus 3 is equal to, by adding corresponding elements, 2 plus 4 is equal to 6, 3 plus 1 4, 1 plus 2 is equal to 3, and 0 minus 3 is equal to minus 3. Here 2 plus 4 6, 3 plus 1 4, 3 and minus 3. This is our A plus B, and if this is A plus B, so implies transpose of A plus B. Using this one we can get transpose of A plus B is equal to, we need to change the every row in the corresponding column. So this one is our first row 6 4, so we will interchange in the first column. So our first column in the transpose matrix is 6 4, and the second row is